Today we are going to be solving some questions on electrode potential. So here is the first question. An electrochemical cell was set up based on systems 1 and 2. Which are these? Write half equations to show what has been oxidized and what has been reduced in the cell. Now take note that I will refer to E naught as the standard electrode potential. So if you look at the values of system 1 and 2, which one is more negative and which one is more positive? You can tell that this is more negative. As a result, that means this equation is going to serve as the oxidation. And definitely this one here, system 2, is going to serve as the reduction. So now, how do we write this equation, this half equation? If you look critically at the system 1, you will see that the equation is actually for reduction, right? As a result of that, we have to convert it to oxidation by reversing the equation. So what do? We just have to write it in the reverse order, which is Fe solid, to give us Fe2 plus. That is the answer. We have just reversed the reduction reaction to oxidation reaction. Now the next one is reduction. Definitely, it is the values that we have here that we are going to make use of, just like that. So we have now, if you look at these equations, these half cells, you will see that the number of electrons on the two half cells are not the same. But because it is a redox reaction, that means that if you have 2 electrons lost from one side, 2 electrons must be gained on the other side. Now we have 2 electrons lost here. Definitely 2 electrons are supposed to be gained right down here, but we just have 1 electron here that is gained. So what do we do in that instance? We just have to multiply all through by 2. So we could put a 2 here, multiply all through by 2, and then we're going to have 2V3 plus Aqueous plus 2E minus. And we are done. Alright, on to the next question. We are going to construct an equation to show the spontaneity of this cell reaction. So in order for us to do that, we have to first of all identify which system is undergoing oxidation and which system is undergoing reduction. So how do we do that? From the values of the E naught. You can see that system 3 has E naught value of 0.00 volts. And system 4 has an E naught value of plus 0.40 volts. Now remember that the more positive the value of E naught, the more tendency of that species to undergo reduction. Definitely, the other system is going to be undergoing oxidation. So can we write the oxidation half reaction now for system 3? So if you look here, the reaction that we have here is reduction because you can see 2 electrons gained here. In order for us to convert it to oxidation, we need to reverse the equation. So we can have Alright, so we have written the oxidation half reaction. Now please take note of the fact that we want to write the full equation. So we have to write the reduction reaction as well. So we can just move on to system 4. We write this. Alright, Looking at this, since it's a redox reaction, that means if 4 electrons are gained from one side, definitely 4 electrons are lost from the other side. Right. So since you can see 4 electrons gained here, it must be that 4 electrons have been lost from the oxidation reaction. But how many electrons do we have here lost? We have 2 electrons. So how do we make that 4? You have to multiply all through by 2, right? So we can multiply all through by 2. And we are going to have 2H2 and 4H plus, 4E minus. Now we have 4 electrons lost here and 4 electrons gained here. Fine. So the two half equations are balanced now. But remember, what we want to write is a complete equation. So what we need to do next is to merge these two equations together. So we are going to have this reactant side here merged together and the product side here merged together. So let me do it this way. So we are going to have 2H2 plus O2 plus 4H plus. Now the products together, 4H plus 4E minus plus 2H2O. Alright, so if you look at both sides of this equation, you will observe that there are some spectator ions. Those are ions that are appearing on both sides. We have 4H plus here and 4H plus here, so they can be cancelled out. We have 4 electrons here and 4 electrons here. So what is remaining? We are going to have 2H2 Right, so we are done. Also go on and divide all through by 2. That way we are going to have H2 gas, and this is going to be half of O2 gas to give us H2O. This is also correct. The next question we want to solve now is to calculate the standard cell potential. Now this is a very simple question to solve. All you just need to know is this equation, which is E naught of the cell equals the E naught for cathode minus the E naught for anode. Now, if you can remember, we identified that this is undergoing reduction and this is undergoing oxidation. Definitely, system 2 is at the cathode and system 1 is at the anode. So what do we need to do now? Just plug in the values, and that is going to be, we are going to have minus 0.26 minus into bracket minus 0.44. And when we do the mathematics of this, you're going to have minus 0.26 plus 0.44. And the final answer is going to be 0.18 volts. I believe you learned a lot from this video, and what I want to ask you is to like this video and also subscribe to my channel to get more of this kind of video. See you next time.